Experiment 1. Let's start. Experiment 1. Write down determination of determination of the refractive index of glass. Determination of the refractive index of glass. Determination of the refractive index of glass using traveling microscope. Using traveling microscope and a block of glass. Using traveling microscope and a block of glass. Using traveling microscope and a block of glass. Right. Okay, listen. So first I'll explain you the theory behind this. Theory is this. Right. Theory is apparent depth and real depth. So you know, if you are observing something in a dense medium from a rare medium, right? So let's say we have an object somewhere here, O, right? And you are observing this from air. So assume this as water and air. Assume this as water and air, right? Simply, this should be a dense medium. This should be a rare medium, right? When a light ray comes from here, right? When a light ray comes from here, we know at this point, it bends away from normal. It bends away from normal. So we'll be observing this light ray somewhere here by keeping the eye somewhere here, right? So what is sensitive to our eye is only the direction of light ray which comes into our eye, right? What is sensitive to our eye is only the direction of light ray which comes into our eye. So this is the direction. We are sensible. Our eye is sensible, right? So it is like it is coming from here. It is like coming from here. Now actual object was here, but the light ray is coming from here. Then we are observing the image somewhere here, right? We are observing the image somewhere here, right? Distance from this point to here was the real depth, the actual depth, RD, real depth. The object is located. Real depth, the object is located. And the distance from here to here is the distance that you are observing the object. This is called the apparent depth. Apparent depth, right? And the displaced part D is called apparent displacement. Apparent displacement, right? Now using this, we have proved this equation. Now I'm not going to prove the equation. I'm just recalling the theory, right? Theory class prove. So what is the equation? If this is, let's say, N2, refractive index of this medium is N2, and if refractive index of this medium is N1, the equation is N1 over N2 equals real depth over apparent depth. Real depth over apparent depth. Right? This is the respective theory for this experiment. Right? Take it down as a theory. N1 over N2 equals real depth over apparent depth. This is a proved equation. This is a proved equation in the class. Right? So I'll be briefing the theories involved because when we are moving forward with the experiments, for you to get an idea about it, right? Otherwise, last week also I told you to go through all the things, everything we have done in optics, because we'll be using all knowledge you have gained throughout these experiments. Right? Take it down. Sadil, go. අදීශ දන්නවනේ වෙනදා වගේ වයිසෙත් විතරයි පොඩ්ඩක් මේ ටිකයි ඇහැල්ලේ right take it down take it down take it down finish. This is the respective theory. This is how the apparent displacement and the apparent depth occurs. Right? Using this, we have proved this equation. Right? For now, this is the only thing needed. N1 over N2 is real depth over apparent depth. N1 over N2 is real depth over apparent depth. Right? Now we have a lot to discuss today. Diagrams එහෙම අඳිද්දී ඉක්මනට අඳ ගන්න. කොළොන්දර ඉක්මනට ray diagrams එක. Ray diagram එක හරියට තියෙන්න ඕනේ. But be faster. Ray diagram එක හරියට තියෙන්නත් ඕනේ. අදිශ ගෙදරින් දැන් නෙමෙයි දාවේ. ගෙදර නෙමෙයි. මට විහාරද කොහෙද කිව්වා පරක්කු වෙයි කියලා. පරක්කු වෙයි කියලා මට විහාරද කොහෙද කිව්වා. ගියේ නෑ. Okay, finished? Right. Then this is what we do. Right. ඊට පස්සේ ලියා ගන්න materials and apparatus. Materials and apparatus. Materials and apparatus. Materials and apparatus. Right. So we are going to measure this using traveling microscope, no? So first of all, we need a traveling microscope. Mention the list. First one, traveling microscope. Traveling microscope. Right. Second one. Second one. A block of glass. A block of glass. A block of glass. Right. Then lycopodium powder. Lycopodium powder. A white sheet. A white sheet. Right. Just by using lycopodium powder also we can do this without using a white sheet. I will explain both methods. Right. දෙකම ලියා ගන්න මම දෙකම explain කරන්න. කොහොමද කරන්න කියලා. Right. So basically this is what we do. Listen. මේක erase කරමු. First of all, traveling microscope should be leveled, right? Before taking any measurement using traveling microscope, it should be leveled, no? Right? It should be leveled. Traveling microscope එක level කරනවා. Level කරාට පස්සේ using what? ඒකේ පොඩි mechanism එකක් තියෙනවා. කොහොමද traveling microscope එක level කරන්නේ? මේවා instruments. Using spirit leveler, right? Using spirit leveler, right? So in most of the traveling microscopes, the spirit leveler is inbuilt, right? Inbuilt එකක් නැත්තම් විතරක් you can use an external one and do it. Right? Externally use කරලා කරන්නත් පුළුවන්. But in modern traveling microscopes, right, it has an inbuilt spirit leveler. Right? ඒකේ තියෙනවා අර එයා බබල් එක මැද්දට ආපු ගමන් ඒක level. Right? Okay, ඒ විදිහට level කර ගන්නවා. Then the stage is leveled. If the traveling microscope is leveled, which means stage of the traveling microscope is leveled. Right? මෙහෙමනේ තියෙන්නේ. If the traveling microscope is leveled, which means this stage of traveling microscope is leveled like this, right? And our microscope is somewhere here. Microscope is somewhere here, right? Consists of the eyepiece and the objective piece. It is somewhere here above, right? Microscope like this, right? So after leveling this, listen, after leveling this, now if you are using the white sheet, if you are using the white sheet, take the white sheet and we are drawing a cross in the white sheet, right? Cross and you can keep the white sheet here, right? Then white sheet you can keep the white sheet here. By adjusting the vertical movement of traveling microscope, because there is no horizontal movement involved here, movements the traveling microscope adjustments right? For horizontal adjustments and vertical adjustments, fine vertical movements and force vertical movements, right? Using fine or force vertical movements, we have to first focus onto this. Focus onto the cross on the paper, right? If the cross of the paper is clearly visible through the crosswires of the traveling microscope, which means it is focused up to this side, no? Microscope and lens focus. Now, if you can see a clear image of this cross on the crosswires, then on the crosswires, if you see a clear image of this cross here, right, we can take the first reading. Say that first reading is x1. Say x. Say the first reading is x, right? So without using the sheet, if you are using this, we can spread some powder here on the stage and we can focus that onto lycopodium powder. Lycopodium powder means that's a very thin powder. It's a yellowish one, right? Right? A yellow colored powder and a very thin one, right? Thin when known, thin powder right? Milk powder thin thick it was right. Now we have a glass block. Glass block now you can keep the glass block here. Glass block now due to the glass block, it should be apparently displaced, no? Right? Then cross displaced now. Then we can observe the image again, but there is not that the real depth that will be displaced. Then you will see the image somewhere above the real image. Okay, apparent depth again, right? Glass if you observe this cross again through the glass, what you are seeing is the displaced image of the cross, no? Right? Displaced image we need to take this upwards. We have to adjust this upwards. Again, we are only using vertical adjustments, vertical movements. Horizontally, horizontal local. Always, when you are using traveling microscope, we will be moving that towards one direction at a time. Right? Traveling microscope use right? Movements are one direction at a time. Now, they are only vertical movements. We are using only the vertical movements, right? Only the vertical movements. Then, after focusing on to this, see, let's say this respective reading is x, and the first reading R1 equals x, and then this is a glass block, right? And the cross is somewhere here now, and we are focusing this again to the glass block like this, and you will be observing the image of this, the displaced image of this, using this, right? Maybe an object. This is the object. This is the image now, right? Now, if I take another reading at here, say y, it gives the respective reading from here to here. Reading right? The last step is we have the glass block kept on the stage like this. We have to spread some lycopodium powder on the block like this, on the block. And again, we have to focus our traveling microscope onto lycopodium powder here, right? We have to focus the microscope to lycopodium powder here, right? Like this. Say this reading is Z, right? The mega focus to this point. Then difference between these two readings gives the real depth of the cube, no? And difference between these two readings gives the apparent depth of the image to the image, right? හරිනේ දැන් රීඩින්ග්ස් තුනක් අපි ගාව තියෙනවා මේ රීඩින්ග් එකේ තියෙන්නේ මෙතෙන්ට එනකන් ලෙන්ත් එකක් මේ රීඩින්ග් එකේ තියෙන්නේ up to the image, right? මේකේ තියෙන්නේ up to the top surface of the glass block, right? දැන් මේක top surface එකේ තිබ්බ රීඩින්ග් එක මේක තමයි bottom surface එකේ රීඩින්ග් එක stage means bottom of the glass block නේ එහෙනම් මේ දෙකේ difference එකෙන් මේකේ thickness එක එනවනේ thickness is real depth ඒ කියන්නේ real depth of this block is real depth of the block is what is the higher reading ZOX. What is the higher reading? See, we are taking this upwards, we are moving this upwards, right? And I'm measuring in a real depth is at minus x, C minus x, right? Come the apparent depth again. Apparent depth is from come the apparent depth measure කරන්න diagram from here to here. Right? measure කරන්න then z minus y, right? Z minus y. When the values then we know n1 over n2 equals real depth of apparent depth. Then using that equation, simply, if these values are known, since these values are known, then my readings vernier scale my values known values. When these values are known, we can easily put that into the equation and find n of the glass block, right? Because we are observing this from the air medium, refractive index of air is known, right? We know n1 over n2 equals real depth over apparent depth, right? n1 over n2 equals real depth over apparent depth. What is n1? n1, which medium? Objects or observers? n1, n2. Make a equation n1 objects medium, n2 observers medium, right? n1 objects medium. Then let's assume n of the glass block as n, right? Then n equals n2 is 1 equals RD means real depth is z minus x, apparent depth is z minus y, right? Then n equals z minus x over z minus y, n, right? Simple thing. Okay, any questions? Ready there now? Right. Write down as a method. Right. Method. Measure in point form. First point. Level the traveling microscope. First point. Level the traveling microscope. Level the traveling microscope. Level the traveling microscope using spirit leveler. On the instrument, using spirit leveler on the instrument. Next point, measure in point form. Steps step wise so this is in order, right? Order experiments always you have to answer in the correct order, right? Second one, spread some lycopodium powder. Spread some lycopodium powder. So can we write white paper as A4 paper? A4 no, it's fine. But there are like different colors of A4s, no? It's better to write than white A4, right? Should be white. White again අපිට මේ හොඳට මේක පේන්නේ නැත්නම් ඒව දැන් අර රේන්බෝ කලර්ස් වගේ දාගන්න පුළුවන්. ඊට පස්සේ වෙන්නේ නැහැ. මේ වලද්දි. Right. What did I say? Spread some lycopodium powder. Spread some lycopodium powder on the stage. On the stage. Spread some lycopodium powder on the stage. Or keep the white sheet. 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 With a cross mark. With a cross mark. Cross කියලා මේක දැම්මත් කවන්න with a cross mark on the stage. On the stage. And focus traveling microscope and focus traveling microscope onto lycopodium powder. Onto lycopodium powder. ඔය lycopodium කියන වචන මතක තියාගන්න. right? කියන හිතන හිතන වලියන්න බෑ chili powder වගේ එහෙම රතු පාට වන්දර පේනවා කියලා එහෙම ලියන්න බෑ ඔය. Focus traveling microscope onto lycopodium powder or cross sign and take the reading. Lycopodium powder or cross sign and take the reading. Lycopodium powder or cross sign and take the reading. Within brackets, write down R1 equals X, right? First reading. I consider that as X. R1 equals X. Right? Then, next point. Next point. Abhi मैं तुना में कब आ रहा हूँ? Comedy ले लिया वाला. That's better. Right? Next point. Keep the glass block on stage. 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 And focus. Traveling microscope. And focus traveling microscope. And focus traveling microscope. To the image of lycopodium powder / cross mark. To the image of lycopodium powder / cross mark. Observing through the glass block. Observing through the glass block. Observing through the glass block. And take the respective reading. And take the respective reading. And take the respective reading. Within brackets, R2 equals Y. And take the respective reading. R2 equals Y. Right? Next point. Spread some lycopodium powder. Spread some lycopodium powder. Spread some lycopodium powder. Spread some lycopodium powder on the top surface of glass block. On the top surface of glass block. on the top surface of glass block and focus traveling microscope and focus traveling microscope and focus traveling microscope onto lycopodium powder and focus traveling microscope onto lycopodium powder and take the respective reading and take the respective reading. Within brackets R3 equals Z. Within brackets R3 equals Z. Within brackets R3 equals Z. Right. Now, take this down. These three diagrams. These are the respective diagrams for first three occasions. Like, මෙතන stage එක තියෙනවා. මම stage එක ඇඳලා නැහැ. ඕන stage එක අඳින්න. Right. If you are drawing the stage is here. Right. I haven't drawn the stage. Right. ඕන stage එක අඳින්න. What is lycopodium powder? A very thin yellowish powder. The reason to use this is that is very thin, and even if you are using this on a liquid, it floats without drowning, right? Very thin powder. And the other thing is the මේ වගේ එක powder එක දැම්මම powder layer එක ගොඩක් thick වුණොත් තමයි අපේ reading එක වැරදි, right? When you spread the powder layer here, if it is more thick, you are going to get a erroneous reading, right? That's why we are using a thin powder. live එකෙන් බණවලුන්ට. Right, finish. Consider refractive index of glass block as n. Right, refractive index of glass block as n. නෑ මේක ලියන්න එපා. මේක ලියන්න එපා. මේක ලියන්න එපා. diagrams විතරයි. ඒකත් ලියුවා. හරි ඒක ඊට පස්සේ දැන් තාම diagrams විතරයි. Right, write down. Write down next point. Next point. Determine refractive index of glass block. Determine refractive index of glass block. Determine refractive index of glass block. Determine refractive index of glass block using following equation. Using following equation. Right. We have mentioned the equation in the theory, right? So that's why I have mentioned this as RD and AD. On a real depth apparent depth right? N1 over N2 equals real depth of apparent depth. Plug these values here. Real depth is the depth from here to here. On make a mark real depth of the glass block is from this point to top surface to bottom surface, right? And the apparent depth is from top surface to this image, right? RD and AD, real depth and apparent depth. Right? Applying the equation, right? And if you don't know about N1 and N2, right? On a theory, N1 is objects medium, and N2 is observers medium. Right? Objects medium and observers medium. Right? Then N is Z minus X over Z minus Y. All X, Y, Z are known values. Then easily we can plug these values and simplify. That's it. right? So we'll see what is given in the guide after explaining everything, right? Right. So basically, first part is done now. First part is done, right? We have another extension for the experiment. Extension එක කරන්න කලින් there are some important things to be known, right? අපි ඒ ටික බලලා extension එකට එමු, right? Write down as remarks. 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 Remarks, right? Write down one by one. First point. First point. Traveling microscope should be leveled. 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 Before starting the experiment, within brackets, using the liquid level or the spirit level, using the spirit level, within brackets, using the spirit level. Next point. Adjust eyepiece of microscope. Adjust eyepiece of microscope. Adjust eyepiece of microscope. Adjust eyepiece of microscope by keeping a white sheet in front of. By keeping a white sheet in front of objective piece. By keeping a white sheet in front of objective piece until a clear image of traveling microscope එකෙන් බලද්දි මොනවද පේන්නේ? Cross wires. Until a clear image of cross wires is seen. Until a clear image of cross wires is seen. Until a clear image of cross wires is seen. Right? Next point. It's better to use a simple magnifier. It's better to use a simple magnifier. It's better to use a simple magnifier when taking readings from traveling microscope. Listen, in some traveling microscopes, simple microscope is also inbuilt. දැකලා තියෙනවද? reading මේ scale එකත් එක්ක පොඩි microscope එකක් තියෙනවා. In some. හරි එහෙම එකක් නැත්තම් තමයි මේ external එකක් use කරන්න කියලා කියන්නේ. In some traveling microscope that is inbuilt. Right? දැන් එහෙම ගොඩක් ඒවා තියෙනවා. Next one. Next one. If lenses of microscope are dirty, clean it using clean it using a cotton cloth and alcohol. A cotton cloth and alcohol. Using a cotton cloth and alcohol. Use करता है वो कहता नहीं कहता നമുക്ക് मैं going करते हैं අරන්ද හැමෝටම හම්බුනානේ ඔය ගත්තා okay next one when moving traveling microscope after taking first reading when moving traveling microscope when moving traveling microscope after taking first reading only vertical adjustments should be used within brackets අර ස්පේස් එක බලලා ඒක තියාගෙන මෙතන ඉඳලා ලියන්න මේ තව තියෙනවා හොඳ ඊටු ටික වීඩියෝ එක බලලා ටක් ගාලා මෙයා කරගන්න what did I say within brackets කියලා කිව්වනේ කිව්වා only using vertical adjustment within brackets fine vertical adjustment or force vertical adjustment right adjustments දෙකක් තියෙනවා traveling microscope එක right අපි measuring instruments වල කතා කරන fine එකෙන් වෙන්නේ for small movements right force means පොඩි lock එකක් තියෙන lock එක unlock කරලා manually you can take it up and down that's the force movements right within brackets fine vertical adjustment or force vertical adjustment right next point this same method can be extended to find refractive index of a liquid as below right see right මේ extension එක guide එකේ නෑ මොකද හැබැයි questions වලට එනවා right හොඳට අහගන්න මේ guide එකේ නෑ if we are using the same setup to find refractive index of a liquid right so first of all we have to have a beaker right have a beaker look at here මේක අඳ ගන්න එපා have a beaker right and put a small needle or a pin into empty beaker then make empty into empty beaker and we can focus this to the pin here right pin එකක් කියලා කියන්නේ නිකන් අපි අල්පනිති කියලා කියන්නේ අන්න ඒ වගේ අල්පනිති කියලා කියන්නේ they are called optical pins අපි optics වලදී කියන්නේ optical pins කියලා right optical pins simply අර අල්පනිති කියලා අපි අනින එක right මේ දෙන්නේ එහෙම එකක් then focus this on to the empty pin right pin එකට focus කරනවා කලින් වගේම reading එකක් ගන්නවා say r1 equals අපි මෙහෙම ගමු r1 කියලා ගමු this reading equals r1 right then you have to fill this with the liquid right water hari මොකක් කරි whatever the required liquid මේක fill කරනවා right දැන් මේ pin එක මෙතන තියෙනවනේ right that is metal ඒක කොහොමද float වෙන්නේ නැහැනේ මේ තියෙන දැන් object එක then when you observe this through the liquid what you are observing is image of this right displaced image then take the reading say r2 right then the last scenario spread some lycopodium powder on the surface right and focus this onto lycopodium powder and take the respective reading r3 right same thing then let's assume refractive index of this liquid as n, refractive index of the liquid as n. Then n1 over n2 is given by real depth of apparent depth. Real depth now is then real depth using these readings. Live value given. What is the real depth now? Real depth R3 can say focus reading, right? R1 can bottom focus reading, then there is R3 minus R1, right? Real depth is R3 minus R1. R3 minus R1. Apparent depth is from the surface to here, no? Then R3 minus R2. මේක පාඩම් කරගන්න එපා මේ concept එක ඔලුවට දාගන්න ඕනේ. ඒ කියන්නේ මේ equation එක පාඩම් කරගන්න එපා. Concept එක ඔලුවට දාගන්න. Then n is given by R3 minus R1 over R3 minus R2. Refractive index of the liquid. Right? මේකත් ඕනනම් මේක මාක් කරලා තියාගන්න. This is the apparent depth and distance from here to here is the real depth. Right? Liquid එක ගන්නත් පුළුවන් using the same method. Right? Take it down. අපි ඉන්නවනේ videographers ලා. We have a lot to do today. මේ diagrams එක මම ඉක්මනට අඳින්න ඕනේ. diagram එක හරියට තියෙන්නත් ඕනේ. ඉක්මනට අඳින්නත් ඕනේ. Mention all now. Mention all of them, right? So simply we are repeating the same experiment to the liquid, right? Liquid එක දාලා කරන විදිය පොඩ method එක දැනගෙන ඉන්න ඕනේ ඉතින්. මේ extension එක ඇවිල්ලා තියෙනවා questions වල, right? It is questionable. Right. Then let's quickly go through what is given in the guide. Now guide එකේ තියෙන මොනවද කියලා නිකන් බලන්න. Right? Determination of right traveling microscope, a rectangular glass block, a white sheet of paper, some lycopodium or any other suitable powder. මේ any other suitable powder කිව්වට මම කිව්වනේ හිතෙන දේවල් ලියන්න බෑ හොඳේ. ඒ නිසා lycopodium කියන එක මත තියාගන්න. milk powder, chili powder වගේ එහෙම ලියන්න එපා හොඳේ මේ. turmeric powder අර එහෙම හරියන්නේ නැහැ. lycopodium කියන්නේ it's a thin one. ඒ යාගේ තියෙන features ඉඳලා තමයි ඒක use කරන්නේ. දැන් milk powder එහෙම දැම්මොත් ඕක මෙතන තියෙන්නේ නැහැ. මේක ඩක් ගාලා යටට යනවා. readings ගන්න බෑ. lycopodium කියන්නේ එහෙම එකක් නෙමෙයි. it's a thin one. අයි දැන් අපි මේ glass block එක උඩ හරි මේක උඩ හරි තියෙද්දි if this was a thick layer you are going to take a erroneous reading. අයි මේකේ 1 mm හරි thickness එකක් ආවොත් ඒක error ගන්න. right එහෙමවත් වෙන්නේ නැහැ. it's a negligible thickness. ඒක තමයි lycopodium use කරන්නේ. right ඒ වචන මතක තියාගන්න. okay the distance from the upper surface right. I didn't mention these values on a table. මෙතන values තුනනේ ගන්න තියෙන්නේ. That's why I didn't mention that on a table. Table එක mention කරේ නැහැ. ගත්ත readings තුන මෙතන තියෙනවා. Right? Glass block එකෙත් මම block එක ගාව mention කරා. Calculate the refractive index of glass as explained. Right? So මේකෙන් calculate කරන්න පුළුවන්. Discuss the actions to be taken to increase the accuracy of the experiment. All right. මෙන්න මේක මට කියන්න බැරුණා. See මේ note එකේ තියෙන එක. By placing the glass block with the longer side vertically to increase the real depth is more accurate. What's the reason? If the longer side is vertical, why the readings are more accurate? Higher the reading, lower the percentage error. Higher the reading, lower the percentage error. Right? එතකොට මේ වගේ reading එකක් ගන්නකොට උස reading එකක් ගත්තොත් low percentage error. Then readings are more accurate. Right? Right, just make it, the layer of powder of glass surface should be very thin. If not, the reading of Z would be erroneous due to the thickness of the layer. අර මම කියපු එක මතක තියාගන්නෝද? ඒකයි අර අපිට එක powders දාන්න බැරි. This experiment could be modified to determine the refractive index of a liquid 2 කියලා තියෙනවා. ඒ part එක දීලා නැහැ. ඒක තමයි මේ. Right? Okay, write down below again. මම මේක පොඩ්ඩක් explain කරන්නම්. මේක මොකද කරන්න කියලා. Next point below this. Next point below this. Keep an optical pin. Keep an optical pin. Keep an optical pin. Keep an optical pin. At the bottom of at the bottom of empty beaker. At the bottom of empty beaker. And take the reading. And take the reading within brackets R1 and take the reading within brackets R1 and take the reading within brackets R1. Next point fill the beaker with the required liquid. Fill the beaker with the required liquid. Fill the beaker with the required liquid. Fill the beaker with the required liquid and observe image of optical pin and observe image of optical pin through the liquid and take the respective reading and take the respective reading within brackets R2 right. Next point, spread some lycopodium powder spread some lycopodium powder on the surface of liquid and focus onto powder and take the respective reading and focus onto powder and take the respective reading focus onto powder and take the respective reading අවුරුදුනේ right within brackets R3 හෙටම night 7 එක තිබ්බනම් අවුරුදු celebrate කරලා ගන්න උඩා right that's it right so basically same steps as before right මම මේ liquid එකේ ටික විතරයි කිව්වේ අනිත් ටික same as before. Right? දැන් මෙහෙමයි මේ experiment එක ආවොත් මුලින්ම මේක අහන්නේ නැහැ හොද. මුලින්ම glass එකේ අහලා තමයි extension එක අහන්නේ. එහෙම තමයි question එකක් එන්නේ. මුලින්ම glass එක ගැන අහනවා as usual ඒකනේ guide එකේ තියෙන්නේ. ඒක අහනවා. ඊට පස්සේ දැන් ඔය in the modern trend of questions always you will be giving a part or two to think out of the box no. Right? ඔය last part එක වගේ දෙනවා පොඩ්ඩක් මේකේ නැති එකක් to think out of the box. Right? To go beyond the frame that you are given here. අන්නේ part එක තමයි මේක එන්නේ. Right? ඒතර modification එක කරන විදිහ දැනගෙන ඉන්න ඕනේ. ඒතර මේක තියෙන්නේ අර stage එක උඩ හොදේ. මම stage එක ඇඳලා නැහැ. Whatever we are measuring using a traveling microscope should be kept on the stage of the traveling microscope. ඒතර මේක අර බිම තියලා ගන්න බෑ. මේක stage එක උඩ තමයි තියන්නේ. පොඩි බීක එකක්. Right. Any questions on this on the first experiment? මේ වීඩියෝ වල ටක් ගාලා ඒක කම්ප්ලීට් කරගන්නද? මේ වෙලාවේ ඇති ගොඩක් පුත් නෑ පැය භාගයට වැඩිද? එනට 45ක්. මේ බලලා මේවා කරගන්න. Right? Any questions? All good? All good? Right. Okay then. Let's move on. Experiment 2. Right, මං කලිනුත් කිව්වා වගේ we are just 16 weeks from the exam. We are just 16 weeks from the exam. ඒතකොට මේ වාර ආයි පස්සේ බලන්න කියලා තියාගන්න එපා. හොඳේ එහෙම බලන්න නැහැ ඕගොල්ලෝ කොහොමද? Right? Optics නම් optics experiments 7 අදින් ඉවරයි. ඊට පස්සේ මේ 7 ආයි questions ලියන්න විතරක් තියාගන්න. Right? කොහොමද papers වල questions එනවනේ. ඒතකොට දැන් අදත් if time permits I'll be discussing few questions. Right? ඒක බලමු. ඒතකොට ඕගොල්ලෝ වැඩ ඉක්මනට කරොත් questions කරන්න පුළුවන්. මේ කොහොම වුණත් මේකයි අර පාඩම් කරන්න කියලා ටයිම් යන තියාගන්න එපා. ඉතින් එහෙම ටයිම් එකක් එන්නේ නැහැ. මේ 16 weeks ඉඳගෙනනේ අපි මේ කතා කරන්නේ. After new year when we are meeting again in the class it will be just 15 weeks from the exam. Right? Next Monday වෙද්දි 15 weeks නේ. ඒතර ඉතින් ඒක හරිම පොඩි ටයිම් එකක්. And you will be busy with all other subjects and everything. Right? එහෙම තමයි හැටි. එහෙනම් මේ මෙතන ඉන්න මේ 8 hours හරි ඒ ටයිම් එක full මේකට engage වෙන්න. Right? Even if you are online or physical online නෑ තමයි ගොඩක් වෙලාවට ඔක distract වෙන්නේ. Right? කොහොම හරි live එකෙන්ම ඔක ඉවර කරන්න try කරන්න. මේ ආයි පස්සට තියාගන්න නේද? මොකද මේක 8 hours වගේ seminar ගන්න. එතකොට ඉතින් 3 hour live එකක් බලන්නෙත් නෑනේ recording එක. place එකට class එක. තියාගන්න ඕනේ. ඒතකොට 8 hours වගේ එකක් බලන්න තවත් අමාරු වෙන්නේ. Right? මේ live එකෙම ඉවර කරන්න පුළුවන් තරමට lazy වැඩි. Right? ඒතකොට අද වැඩේ කරගත්තා ඉවරයි. හෙට කොහොමත් classes නැතුව ඇදිනේ. මගේ නෑ වෙන classes නැතුව ඇදිනේ. 13 කියලා කියන්නේ it's a public holiday. හරි. ඒතකොට ඉතින් හෙට පොඩ්ඩක් නිදාගෙන නැගිටින්න. අදින් වැඩේ ඉවරයි. ඒතකොට කියන optics වල තියෙන experiments හතේ තිබ්බ burden එක ඉවරයි. right? ඒතර කලින් එකේ waves එකත් එහෙම ඉවර කරේ. මම ওই විදිහට thermal එකයි electricity එකයිත් කරනවා. ඒතර මේ ආයි මේක අර බලන්න කියලා තියාගන්න නම් එපා. ඒ කියන්නේ අද මේ වැඩේ කරලා ඉවර කරගන්න. That's it. Then you can practice more questions with the papers. Right? Okay, let's move on. Experiment 2.